If you bite into a raw lemon, you expect a sharp, acidic sting. But under the right conditions, your tongue registers the flavor of sweet pink lemonade without a single grain of sugar added. This sensation stems from a temporary biological adjustment, a fleeting shift in how your nerves process chemistry. We usually think of flavor as a physical property of the food itself. In reality, taste is a psychological interpretation constructed entirely by the brain. Your tongue serves as a chemical sensor, relaying raw data. Your brain then receives that information and assigns it a label, like sweet or sour. Intercepting that signal on the tongue allows us to recalibrate the flavor profile sent to the brain before it is ever processed. For most of human history, seeking out sugar was a requirement for survival. Detecting simple carbohydrates meant finding the high-density calories needed to sustain life. In the modern world, this ancient drive has become a liability, pushing us toward chronic health issues in an environment of caloric overabundance. Biological sweet receptors are highly selective. They only activate when a molecule with a specific geometric profile docks perfectly into the receptor site. Scientists previously believed this biological docking was the only way to trigger the sensation of sweetness. Without the physical presence of sugar, the receptor remained silent. Finding a way to decouple the physical molecule of sugar from the perception of sweetness could provide a way to satisfy our evolutionary cravings without the nutritional cost. That mechanism is found in the miracle fruit, a berry native to the African continent. In West Africa, indigenous populations historically chewed the fruit before meals to make acidic, fermented foods more palatable. The active component is a massive macromolecule called miraculin. Miraculin binds directly to the tongue's sweet receptors. At a neutral pH, it remains silent. Introduce an acid, like lemon, and the receptor's physical shape shifts. Miraculin clicks into the active slot, firing a sweet signal to the brain. The acid is still physically touching the tongue, but the hijacked sweet signal is so intense that it masks the sourness entirely. To prove this effect, undergraduate neuroscience students at Christopher Newport University tested the mechanism on human subjects. This chart shows the results. After eating the berry, the sweetness ratings for highly acidic items like lemon, grapefruit, and cider vinegar increased significantly. At the same time, the subjects reported a sharp drop in the perceived sourness of those exact same foods. Importantly, the data remained unchanged for bitter and salty foods. The protein only reacts to acid, meaning it has no effect on the bitterness of broccoli or the saltiness of a cracker. The effect lasts about 30 minutes, and because it only changes perception, high consumption of acidic foods can still physically damage oral tissues, even if they taste like candy. The study confirms that we can reliably and selectively override human sensory data using a biological catalyst. Researchers are now looking past the novelty of the berry to find practical medical applications. Many chemotherapy patients suffer from dysgeusia, a condition that makes all food taste intolerably metallic or sour. Pilot studies show that using the fruit to mask these negative flavors can make food palatable again, helping patients maintain nutrition and strength during treatment. It also shows promise for diabetics, providing the sensation of sweetness from acidic foods without triggering an insulin response. By managing how the brain interprets a signal, we can address physical symptoms that traditional medicine often struggles to treat. If we can engineer this specific flavor override, it suggests we may find ways to map and adjust other sensory inputs. In the future, adjusting a meal's pH could allow us to experience nutrient-dense, acidic fruits with the same intensity and pleasure as a decadent dessert. Ultimately, the sharp sourness of a lemon isn't an objective truth, it's a biological calculation. As we learn to recalibrate these internal calculations, we gain the ability to choose how we experience the world around us.